Chapter 2 Rosetta Stone. The following chapter is excerpted from the first chapter of Jerry Vassilatos' book, Secrets of Cold War Technology, the HARP project, and what behind it, and is reproduced here courtesy of Adventures Unlimited Press.
The following chapter is excerpted from the first chapter of Jerry Vassilatos' book, Secrets of Cold War Technology, the HARP project, and what behind it, and is reproduced here courtesy of Adventures Unlimited Press. James Clerk Maxwell predicted the possibility of the existence of electromagnetic waves. In theoretical discussions conducted to better explain his theories, Maxwell asked his readers to speculate about two different types of electric waves that may exist in nature. The first consideration concerned longitudinal electric waves, a phenomenon that required the presence of a variable concentration of electrostatic field lines. Such a pulsation of density and discharge of electrostatic fields could arise only under the condition of the existence of a unidirectional field, the vector of which would be fixed in one direction. The only variable allowed for the generation of longitudinal waves was the field concentration. Subsequent propagation along the electrostatic field lines led to pulsating pressures of the charges, and these pulsations moved in one direction. These electric sound waves were rejected by Maxwell. He concluded that such states could not be achieved. His second reasoning concerned the existence of transverse electromagnetic waves. They required a rapid change in the electric field along a fixed axis. Electrical lines propagating through space may have had to swing back and forth under the influence of their own momentum, while at the same time moving away from their source at the speed of light. The corresponding forces, which were exact copies of the vibrations in the source, had to be detected at considerable distances. Maxwell inspired experimenters to search for such waves, suggesting possible ways to achieve the result. Thus began the great campaign for electromagnetic waves. In 1887, Heinrich Hertz announced that he had discovered electromagnetic waves, which was no small achievement for that time. In 1889, Nikola Tesla tried to reproduce Hertz's experiments. In his elegant laboratory on South Fifth Avenue, he repeated with absolute precision all the conditions of Hertz's experiment, but found that he could not obtain the effects reported. Nevertheless, the equipment produced the effects that Hertz required. Tesla began experimenting with short and powerful electrical discharges using capacitors charged to very high voltages. He discovered that with the help of such sharp discharges, it was possible to explode thin wires. Vaguely feeling that he had stumbled upon something important, Tesla abandoned these experiments, concentrating on the mystery, suspecting that Hertz had somehow mistaken electrostatic induction, or electrical shock waves in the air caused by electrical discharge, for real electromagnetic waves. In fact, Tesla even visited Hertz and personally proved his observations to Hertz, who, convinced that Tesla was right, concluded that his conclusions were correct and was willing to deviate from his thesis. Hertz was truly disappointed, and Tesla deeply regretted that he had to do this to a respected academician while proving the truth. But while continuing his own experiments to identify electrical waves, Tesla made a chance observation that forever changed the course of his experimental research. In his own attempts to understand electrical waves, where he felt that Hertz was not finding the truth, Tesla developed a powerful method by which he hoped to generate and capture real electromagnetic waves. Part of his apparatus required the use of a very powerful bank of capacitors. This capacitor bank was charged to a very high voltage and immediately discharged through a short copper bar. The resulting explosive discharges produced some phenomena that greatly impressed Tesla, as they far surpassed any electrical effect he had ever seen. There was some secret here, and he had to reveal it. The instantaneous sparks, which he called explosive discharges, were capable of vaporizing wires. They resulted in very powerful shock waves that hit him with great force over the entire surface of his body. Tesla was extremely intrigued by this amazing physical effect. More precisely, he was completely absorbed in studying these shots of extraordinary energy than electric sparks. These electrical impulses produced effects that were usually associated only with lightning. The explosive effects reminded him of similar events he had observed with high-voltage direct current generators. A familiar experience among workers and engineers occurred during the ordinary closing of the switch of a high-voltage dynamo. This often resulted in a sensitive electric shock, taken for granted, attributed to residual static charge. This dangerous condition only occurred during sudden switching on of high-voltage direct current. A corona of lethal static charge burst directly from high-voltage conductors and often found a path to the ground that included workers and operators. In long cables, this sudden charging effect produced a bristle of bluish needles emanating from the line into the surrounding space. This state occurred immediately at the moment the switch closed. The bluish, sparkling crown disappeared after a few milliseconds, along with the life of any unfortunate person it hit. After this short effect ended, the systems behaved as expected. This phenomenon disappeared when the charges slowly saturated the lines and systems. After this short flash, the currents flowed smoothly where they were intended. This effect was detrimental only in small systems, but on large regional power grids that used impressive voltages, it was lethal. People were dying from this effect, which spread its wide, lethal electrostatic corona of sparks through power system components. Although the generators were rated for several thousand volts, these mysterious surges produced voltages of hundreds of thousands, even millions of volts. The problem was solved when well-insulated and grounded relay switches were used. The engineering research carried out by that time concerned only those properties of energy systems that related to the steady state of energy production and consumption. Now it has become clear that large systems require taking into account both normal and transient operating modes when designing. Accommodation for the dangerous initial overcharge was a new feature. Research into this effect became the main goal of energy companies for many years, and fuses and spark gaps became the subject of many patents and articles. Tesla knew that the strange supercharging effect was observed only when the dynamo was connected to long transmission lines, just as in the case of his explosive capacitor discharges. Although both of these cases were completely different, they produced similar effects. The instantaneous surge provided by the dynamo appeared super-concentrated in extended lines for a short period of time. Tesla calculated that this electrostatic stress concentration was several orders of magnitude greater than any dynamo of the time could produce. The actual energy was somehow amplified or transformed. But how? Engineers concluded that this was an electrostatic blocking effect. Many believed that this was the action of charge bucking, when a powerful source was unable to transfer charge through the system quickly enough. The mystery was that the impedance of such systems seemed to affect the charge carriers before they could escape the dynamo terminals. It was like when you quickly slap your hand on water, the surface seems hard. It was the same with electric force. Charges accumulated in front of a barrier that seemed like a solid wall, but this effect only lasted during the impact. Once the charge carriers were picked up by the electric field produced, the charges jumped along the line in all directions. A short-term supercharging effect was observed during the distribution of charges, quickly filling the entire line and system. Thus the dynamo became the site of a small shock wave. Tesla began to wonder why electrostatic fields could travel faster than charge itself. This riddle puzzled him. Was the field an entity that only served as a drive for more massive particles? If this were so, then what did the field itself consist of? Was there a field of tiny particles? More and more questions arose. Despite the amazing ideas that his research generated, Tesla also saw a practical application that he had not previously thought of. Thinking about the supercharge effect of a dynamo gave the idea for a new experimental apparatus. It greatly outperformed the capacitor bank, used in attempts to detect electrical waves. The source of the electric field was a simple high-voltage direct current generator. Tesla understood that the resistance of lines or components on the side of the dynamo was an insurmountable barrier that charge carriers could not jump over. This barrier created a cumulative effect. The electrostatic charges were practically stopped and were momentarily contained by the resistance of the line. This barrier existed for a short millisecond time interval when the switch was closed. The instantaneous application of forces against this imaginary barrier compressed the charge to a density that could not be achieved using ordinary capacitors. A short application of force, the impact of particles on a resistance barrier, ultimately caused this unusual state of electrical condensation. This is why the wires in his past experiments often exploded. The analogy with steam engines was unmistakable. Large steam engines had to be started with great care. It required consultation with old and experienced operators who knew how to warm up the engine without breaking the valves, causing a deadly explosion. If started too quickly, even very large steam engines could explode. The steam had to be released into the system carefully until it smoothly and gradually filled every nozzle, line, and component. Here, too, a mysterious bushing effect was observed, where a large volume system behaved as if it had an unusually large resistance to any force applied suddenly. The academic world of experimenters was still busy with his past discovery of high-frequency alternating currents. This meant that Tesla was the only one who studied pulsed discharges. He received explosive impulses not previously observed in laboratories. Each component was carefully insulated, and he used insulated conductors and rubberized clothing to achieve complete safety. Tesla had made extensive observations of electrostatic machines capable of strongly charging insulated metal conductors, but this demonstration went beyond simply charging the conductors by suddenly closing a switch. This effect generated a jumping charge, the like of which Tesla had never observed. Whatever conditions he used for previous systems, he has now learned to maximize the effect. By balancing voltage and resistance at a constant capacitance, Tesla learned to continuously create a state of supercharge of such a force that no existing device could generate. Experimental observations showed that the usual discharge of a capacitor generated an oscillating current, which one might say darted between the plates of each capacitor until it completely spent its energy. The high voltage of the dynamo created such a powerful unidirectional pressure on the compacted particles that changing their state became impossible. The only possible solution was hesitation. In this case, the charges created a long series of movements and stops until the supercharge disappeared. Any parameters that amplified such fluctuations limited the expression of the full energetic effect of the supercharge from the energy source, and it was precisely this state that Tesla sought to achieve. Undoubtedly, he spent a huge amount of time creating various ways to block each vibration and other complex current phenomena that could hasten the supercharger's loss of its concentrated energy. He needed a single super impulse going in one direction. When all the vibrations and leaks were eliminated, new strange effects appeared. These powerful phenomena with high penetrating force have never been observed when working with high-frequency currents. The rapid closing of the switch now sent a penetrating shock wave through the laboratory, which could be felt by the sharp impact and penetrating electrical stimulation. I'll give you an injection. The face and hands were especially sensitive to the explosive shock waves, which also produced a funny, tingling effect at close ranges. Tesla was convinced that particles of materials that reached a vaporous state literally burst out of the wires in all directions. To better study these effects, he positioned himself behind a glass screen and continued his research. Despite the screen, both the shock waves and the tingling effect continued to be felt, which puzzled the researcher a lot. This anomaly piqued his curiosity because no one had observed anything like this before. This phenomenon, stronger and more penetrating than the usual electrostatic charge of metals, literally pushed a high-voltage charge into the surrounding space, which gave rise to a tingling sensation. The injections lasted for a small fraction of a second. At the moment, the switch closed. But Tesla was convinced that these strange effects were simply due to the propagation of ionized shock waves in the air, like a highly ionized thunderclap. Tesla conducted a new series of experiments to measure the pressure of the shock wave over large distances. He used an automatic disconnect switch. When configured correctly, it became possible to obtain a more controlled repetition of the effect when turned on. In addition, it allowed for remote measurements that shed light on the phenomenon of screen penetration. Voltage control was carried out by changing the rotation speed of the high-voltage dynamo. After setting up these components, Tesla was free to move around the room and take measurements. Wanting also to avoid prolonged exposure to pressure from blows and sparks, Tesla protected himself with special materials. The application of rapidly interrupted high-voltage direct current resulted in the emission of piercing beams that could be felt at great distances from their super spark source. In fact, Tesla felt the pricks even through his special material shield. Whatever was released from the wires when the switch was closed, it easily penetrated the glass and copper screens. It seemed to make no difference what they were made of. The effect penetrated through any substance, as if there were no screen at all. Here there was clearly an electrical effect that penetrated directly through space without material intermediaries. Radiant electricity. The observed phenomenon violated the principles of electrostatic charge discovered experimentally by Faraday. Emitted electrostatic particles typically spread over the surface of the metal shield. They do not penetrate deep into the metal. The new effect had non-electrical characteristics. Tesla was genuinely intrigued by this new strange phenomenon and began to study the literature in search of references to its properties. He found no such references, except for the half-forgotten studies of two experimenters. In the first case, Joseph Henry observed the magnetization of steel needles by a powerful spark discharge. The unusual thing about this experiment, carried out in 1842, is that the Leyden jar, the sparks of which produced the magnetization, stood on the top floor of a building that is usually impenetrable to electricity. Brick walls, thick oak doors, heavy stone and iron cladding, tin ceilings. Moreover, the needles were placed under the vault of the basement. How could sparks have such an effect on needles through natural barriers? Dr. Henry was convinced that the spark created special rays similar to light, and it was these penetrating agents that were responsible for magnetization. The second such incident occurred in 1872 in a high school building in Philadelphia. Elihu Thomson, a physics teacher, was looking for a way to make the sparks from Ruhmkorff's large spark coil more visible for a lecture. Having connected one pole of the coil to a pipe of cold water, Thomson was startled by the fact that the color of the sparks changed from blue to white. Wanting to enhance this effect, Thomson connected the other pole to a large metal sheet of the table. After turning on the coil, a deafeningly crackling, dazzling white spark appeared, visible even from the back rows. Wanting to show this experiment to his colleague, Edwin Houston, Thomson approached the door and was suddenly stopped. Touching the bronze doorknob on the oak door, he received a sudden, sharp electric shock. Turning off the Ruhmkorff coil, Thomson found that the effect had ceased. After discussing what happened with Edwin, They started the device again. The stabbing effect was repeated. Then both gentlemen began to run around a huge building made of stone, oak, and iron, with electrically insulated metal objects. Each touch of a penknife or screwdriver to any metal object, regardless of the distance to the coil and the degree of insulation from the floor, generated long continuous white sparks. The results of the study were described in a short article in Scientific American that same year. As Tesla studied each of these early observations, separated by a period of 30 years, he felt that they were similar to his discovery. Each of these cases was caused by slight variations of the same phenomenon. Quite by accident, each experimenter achieved the manifestation of the supercharge effect. In Dr. Henry's case, the explosion phenomenon manifested itself as a single flash, as an electrostatic machine was used to accumulate the initial charge. The second case was special because it showed a continuous and long-lasting supercharging phenomenon. This effect was rare because it usually required very precise electrical parameters. Tesla derived this from the simple fact that this effect was extremely rarely observed in laboratories around the world. But he was lucky to quickly notice the anomalous attributes of this phenomenon. Tesla knew that, despite the strong penetrating effect in each case, only he was able to achieve the full and maximum manifestation of supercharge. His device had no equal. It was guaranteed to be able to release the essence of the electrostatic field, which was unattainable for other devices. Although Tesla made this discovery in 1889, a preliminary review of the effect was not published until after a long series of experiments. The Dissipation of Electricity, published before Christmas 1892, was Tesla's turning point. It was from this moment that he completely abandoned research into high-frequency alternating currents. Completely moving away from field research, Tesla began to describe shock waves and other effects of pulses. In addition to those physical sensations, which he described with characteristic restraint, Tesla also drew attention to the gas aspects of the phenomenon. He discovered that the sharply charged wires in his experiments produced strange gaseous currents when immersed in an oil bath. At first, he attributed this phenomenon entirely to the gas absorbed by the conductor, but he soon discovered that this effect continued for a long time from the same wire, and no amount of ordinary absorbed gas could account for it. Definitely, in this case, currents arose in the oil, breaking off from the ends of the charged wire so strongly that they visually compressed the oil, forming cavities, sometimes up to 5 centimeters deep. Tesla began to study the true nature of the light gas escaping from the ends of the wire immersed in oil. He prepared a series of lengthy experiments to find out the real cause and nature of these amazing gas pulses. In his paper, Tesla describes the waves passing through the screen as sound waves of electrified air. However, he made a startling description of the sound, heat, light, pressure, and shock he felt as the effect passed through the copper plates. Taken together, they revealed the presence of a carrier with a gaseous structure, that is, one that consists of independent carriers capable of free movement. Since air was definitely not such a carrier, what was he talking about? Below in the same article, he clearly states that, besides air, there is another carrier. With the help of successful experimental equipment, Tesla discovered several facts regarding the formation of his effect. Firstly, the cause of it, no doubt, was the interruption of the current. It was when the switch was closed, at the moment of its making and breaking, that the effect broke out into the surrounding space. It was uniquely tied to time, the duration of the impulse. Secondly, Tesla discovered that a prerequisite was that the process occur in the form of a single impulse. Repeating the shock was unacceptable. The effect did not appear a second time. On this occasion, Tesla made brief notes, describing the role of capacitance in the circuit emitting a spark. He found that the effect was greatly enhanced if a capacitor was placed between the spark gap and the dynamo. The dielectric of the capacitor both provided impressive energy to produce the effect and served as protection for the dynamo windings. The effect could also be greatly enhanced by increasing the voltage, speeding up the opening, and shortening the switch's closing time. Until now, Tesla used switches with rotating contacts to produce his unidirectional impulses. When these mechanical pulse systems could no longer cope with the increase in the effect, Tesla began to look for more automatic and powerful devices. He found this circuit breaker in the form of special electrical arc arresters. The high voltage output of the DC generator was connected to the paired conductors through a new arc mechanism, which was a very powerful permanent magnet mounted across the path of the arc discharge. The discharge arc automatically and continuously arose and went out under the influence of a magnetic field. To achieve the required rare effect, it was necessary that the capacitor and connecting wire lines be selected in such a way that the receipt and discharge of the required electrostatic charge occurred in an intermittent, unidirectional manner. Tesla created such a circuit to look like a pulsating jet when no back pressure interferes with the powerful flow. The electrostatic charge increased to its maximum and discharged very quickly. The constant use of a high-voltage dynamo exerted pressure on the circuit, which successfully generated a continuous process of charge, rapid discharge. The Tesla effect could arise under this, and only under this condition. The impulses literally flowed through the apparatus from the dynamo. The capacitor, spark gap, and its connecting wires behaved like a vibrating valve. The high-voltage dynamo remained the true electrostatic source in the apparatus. Tesla appreciated this fact well, feeling the painful effects radiating into space. It was obvious that the dynamo was somehow changed by the addition of these pulsating valve circuits. The dynamos he used provided lethal voltage that could kill a person. The valve circuits amplified the strange radiation of the deadly energy of this field. Somehow the dynamo's energy erupted into space with dangerous and painful force. But how? In what mysterious way was such a state achieved? The result of a series of experiments gave rise to a new concept for Tesla. He had, of course, discovered what was involved in his mysterious shock field effect. It was radiant electricity. Tesla first carried out elaborate, lengthy studies to understand the true nature of this new electrical effect. He realized that the strange shock field was actually being emitted into space from a pulse apparatus. If it was electrostatic energy, it was more powerful and more penetrating than any electrostatic field he had ever observed. If it was just an intermittent electrostatic field, then why was its strength so great? Tesla began to become convinced that he had discovered a new electrical force and not a third-party effect of already known forces. It was for this reason that he often described his effect as electrodynamic or more electrostatic. By carefully selecting the associated parameters of the circuit, Tesla learned to produce extremely fast series of unidirectional pulses when necessary. When the pulses were short, intermittent, and precisely sequenced, Tesla discovered that the shock effect could spread over a very large area with virtually no loss of intensity. He also found that the damaging effect easily penetrated bulk metal shields and most insulators. By developing ways to control the number of pulses per second and the time intervals between successive pulses, he began to discover more and more new effects. The duration of each pulse had its own special effects. Feeling the stabbing blows, even while behind the screen at a distance of 15 feet from the apparatus, Tesla immediately thought about the opening prospects for transmitting electrical energy without wires. Tesla realized for the first time that electroshock waves offered much greater potential for changing the world than even the use of his polyphase alternating current system. Tesla intended his discoveries entirely for the whole world. Radiant electricity had special characteristics unknown to world science. Working with a simple but powerful incarnation of his apparatus, Tesla discovered that radiant electricity could produce powerful electrical effects at a distance. These effects were not alternating, nor were they ordinary transverse waves. These were longitudinal waves consisting of successive shock waves. The passage of each shock wave, followed by a short neutral zone, generated a radiant field. The vector components of these shock waves were always unidirectional. Intermittent shock waves were capable of influencing charges in the direction of their propagation. Objects placed near the device acquired a strong electrical charge, which retained its sign for several minutes after the magnetic discharger was turned off. Tesla found a way to enhance these effects of charging of the same sign using just an asymmetrical arrangement of a magnetic spark gap. By placing the magnetic spark gap closer to one side or the other of the charging dynamo, it was possible to select and design a force with a positive or negative charge vector, positive and negative electricity. Thus it became possible to transfer or receive charge from any object in the space covered by the field. This was a new electrical force. Tesla realized more than ever that he was in uncharted territory. The fact that these radiant forces propagated like rays of light distinguished them from Maxwell's electromagnetic waves. Tesla wanted to determine the effect of gradually decreasing the duration of the pulses. This work required great experience and precautions. Tesla knew he was putting himself in mortal danger. By controlling the speed of the spark extinguishing process in a direct current magnetic arc, Tesla released a new spectrum of light-like energy into the space of his huge laboratory. The world has never seen this type of energy before. Tesla discovered that the duration of the pulse itself determined the effect of each small segment of the spectrum. These effects were completely different from each other and were endowed with strange additional qualities not previously seen in nature. A series of impulses, each lasting more than 1/10 of a millisecond, generated pain and mechanical pressure. In this radiant field, objects vibrated noticeably and even moved when the force field reached them. Thin wires exposed to brief bursts of radiant field evaporated. Pain and physical movements occurred with impulses lasting equal to or less than 100 microseconds. With pulses lasting 1 microsecond, strong physiological heating was felt. A further decrease in the pulse duration led to a spontaneous glow, filling the rooms and vacuum flasks with white light. At such pulse frequencies, Tesla achieved the appearance of effects that were usually characteristic of the energy of electromagnetic waves of visible light. Shorter pulses generated currents that filled the room with cool currents and were accompanied by a feeling of anxiety and restlessness. There was no limit to the reduction in pulse duration. None of these energy pulses could be repeated using high-frequency harmonic oscillations. Some researchers were able to reproduce these effects because they understood the absolute necessity of studying the parameters set by Tesla. These facts were explained by Eric Dollard, who also successfully obtained the strange and varied effects that Tesla discovered. By 1890, after a period of intense experimentation and equipment design, Tesla described the set of components necessary for the practical application of a radiant electrical energy distribution system. He had already discovered the amazing fact that pulses lasting less than 100 microseconds may not be felt and cause no physiological harm. He planned to use this fact in his electricity distribution system. Moreover, shock waves lasting 100 microseconds penetrated any substance, making them an ideal form for energy transfer in cities that required large amounts of energy. That same year, Tesla made an even more surprising discovery when he placed a long, single-layer cylindrical copper coil near a magnetic spark gap. The coil, which was about 60 centimeters long, behaved differently than straight copper tubes or other objects. A coil of thin copper wire was covered with a crown of white sparks. The corona eddies were very long and flowed in silver-white streams, soft discharges that seemed to be significantly higher in voltage. These effects were greatly enhanced when a single-layer cylindrical coil was placed in a turn of wire coming from the spark gap. Within this shock zone, the cylindrical coil was surrounded by an explosive flash that hugged its surface and erupted from the open end of the coil. It seemed as if the shock wave was repelled from the surrounding space to connect with the coil in a strange, attractive preference. The shock wave flowed into the coil at right angles to the winding, which was incredible. The sheer length of the discharges jumping from the crown of the cylindrical coil was incredible. If a spark of 2.5 centimeters jumped in the magnetic spark gap, then white flickering discharges flowed from the coil more than 60 centimeters. These discharges were comparable to the size of the coil itself. It was an unexpected and unknown transformation. There was an action here that was almost electrostatic in nature, although he knew that academic circles would not allow that term to be used in connection with this situation. Electrostatic energy does not oscillate like shock waves do. Explosive shock waves have characteristics unlike those of any existing electrical machines. Yet Tesla suggested that the shock wave, for a short moment of its explosive manifestation, was more similar to an electrostatic field than any other known electrical phenomenon. In electrostatic friction machines, where currents and magnetism are minuscule, a very energetic field fills the space between the radiant lines. This dielectric field typically passes through space, slowly growing as charges accumulate. There was also a case here where the DC generator produced high voltage. This voltage charges the insulated copper coil, rising to its maximum value. If all the quantities in the circuit were in a certain combination established by Tesla, then the charge suddenly collapsed. The time of this collapse had to be shorter than the required interval for charging the coil. The collapse occurred when the magnetic spark gap interrupted the arc. If the circuit was configured correctly, then oscillations in the opposite direction never occurred. The unidirectional sequence of charge-discharge pulses caused a very strange field to spread outward, which slightly resembled a stuttering or intermittent electrostatic field. But these terms cannot successfully describe the state of the powerful radiant effect actually measured around the apparatus, exceeding all expected electrostatic quantities. Calculating the ratios of these discharges confirmed their impossibility. By performing standard transformation ratio calculations, Tesla could not calculate the enormous effect of voltage amplification. The usual relationships did not help, and Tesla hypothesized that the effect was entirely subject to the radiant transformation rule, which obviously required experimental determination. Subsequent measurements of the discharge length and the parameters of the screw coil provided him with the necessary mathematical relationships. He discovered a new law of induction in which radiant shock waves actually amplified themselves when colliding with segmented objects. Segmentation was key to creating this impact. Radiant shock waves entered the helical coil and were thrown out through its surface from one end to the other. This shock wave did not pass through the coil, winding at all, behaving on its surface like air on an airplane wing. The gradual increase in electrical pressure was measured along the entire surface of the coil. Tesla clearly established that the voltage could be increased to an impressive 10,000 volts per inch of coil height. This meant that a 24-inch coil could collect radiant shock waves with an initially measured input voltage of 10,000 volts and raise it to a maximum value of 240,000 volts. Such a voltage ratio was previously impossible for devices of similar size and simplicity. Tesla subsequently discovered that the output voltage was related to the resistance of the coil turns. Higher coil resistance resulted in higher voltage across the coil. He called his breaker primary, and the cylindrical single-layer coil placed inside the shock zone, secondary. But he never compared these terms with those used in conventional electromagnetic transformers. His discovery was completely different from magnetic induction, and there was a reason for this. To introduce a real outlandish formulation, there was one phenomenon that frustrated Tesla at times. He measured zero current in these long copper secondary coils. He determined that the current that should have appeared was completely absent. The net voltage increased with every centimeter of the coil's surface. Tesla constantly referred to his laws of electrostatic induction, which few understood. He called the combination of his chopper and secondary cylindrical single-layer coil transformer. Tesla's transformers were not electromagnetic devices. They used radiant shock waves and produced pure voltage without current. Each transformer conducted only a specific pulse duration with a specific strength. It followed that each of them had to be tuned by adjusting the spark gap to a certain pulse duration. Changing the length of the arc provided such adjustment. When each transformer was tuned to its own characteristic response, like resonance, pulses could flow smoothly through the system, like gas in a pipe. Having discovered gas dynamic analogies that were consistent with the available data and were a good estimate in this regard, Tesla began to study whether the white flame of discharges, so different from what he had previously seen, was a gaseous manifestation of electrostatic force. There were a considerable number of experiments in which their truly gaseous nature was clearly revealed, so unlike anything electrical. The way in which radiant shock waves flowed through the conductive windings in white, shimmering laminar jets brought a new revolution to Tesla's thinking. Voltage pulses crossed the surface of the secondary coil like gas pulses under increasing pressure. Until the gaseous pulses reached the free end of the coil, they flowed along its copper surface without penetrating inside. Tesla called this specific phenomenon the skin effect. In this respect, the discharge behaved very similarly to a gas moving over the surface of a pipe. Moreover, when a metal tip was attached to the top terminal of one of his transformers, the flow became more directed. He behaved like a stream of water in a pipe. When the white twisting stream was directed at distant metal plates, it injected electrical charges into them. This appearance of charge could be measured as a current at the receiving end. In the transmitting space, however, no current was generated. The current appeared only in the receiver. Eric Dollard found that such a flux was released into the space surrounding Tesla pulse transformers that the received current could reach hundreds and even thousands of amperes. But what did this mysterious stream consist of? Tesla struggled with the uncertainty that his discharge phenomenon could be ordinary electricity behaving in an unusual way. But could electricity have such a smooth, soft, writhing nature? The electricity he was used to was shocking, hot, burning, deadly, piercing, stabbing. All its attributes were irritating. But this discharge phenomenon, whether it was cold or warm when touched, remained soft and gentle. It couldn't kill. Even the way the pulse exploded, creating a bright white discharge of incredibly amplified voltage, was similar to the behavior of gas escaping from a pipe under pressure. These thoughts led Tesla to the conclusion that this effect was not purely electrical in nature. By studying the white flame in more detail, Tesla discovered why the corona of the operating coil had no measurable electric current. The usual heavy charge carriers, electrons, could not travel as fast as the radiant pulse itself. Stuck in the crystal lattice of the coil, the electrons became motionless. None of the electrons moved around the coil at all. The emitted pulse that moved along the surface of the coil was not, therefore, electronic in nature. In addition to everything, Tesla discovered an amazing phenomenon that resolved all doubts regarding the nature of the energy carriers in his apparatus. Tesla installed a very heavy U-shaped copper bus bar connecting both legs directly to the arrestor. Several incandescent light bulbs were located between the legs of the U-shaped bus. Their arrangement formed a short-circuited circuit. The lamps glowed with a brilliant, cold, white light, while they themselves were short-circuited by a thick copper shunt. This was uncharacteristic of ordinary electricity, brightly glowing, but at the same time cold lamps showed that another energy current runs through the short-circuited circuit. Those who observed this experiment expected that during its execution the breaker circuit, or even the dynamo itself, would burn out. Instead, they saw a miracle. The lamps glowed with extraordinary brightness. This simple demonstration was just one piece of evidence that Tesla's theories were right. Electronic charges prefer a circuit with less resistance and must travel around incandescent lamps along a copper shunt. The radiant current in this situation preferred the opposite principle. This was probably the case because the currents were not electric. Tesla constantly used this demonstration to show the separation of electronic currents from neutral currents. There remained one simple question, the answer to which would provide the necessary information to create a new technology. What exactly separated or fractionated the different transporters in his transformer? It was a geometric coil configuration that inadvertently separated each component. The electrons were trapped in the wire, while the radiant pulse was released above the surface of the coil as a gaseous pulse. The electrons would have to pass through the wire, but during each pulse period, they would be blocked by the line resistance. Thus, the gaseous mobile carriers were released and flowed over the wire, the impulse traveling along the outer surface of the coil from one end to the other. This was evidence that the electrical discharges definitely consisted of several moving particles simultaneously. Now Tesla understood why his high-frequency alternating charges from his first experiments never showed such powerful manifestations. It was the intermittency, the violent pulse discharge, that gave this unexpected gaseous component the ability to move freely. Impulses, unidirectional impulses, were the only way by which this potential could be released. Sinusoidal oscillations were absolutely useless in this regard. Moreover, since the oscillations could not release the second gas dynamic component, they remained useless and had pitiful power. Tesla forever began to regard his high-frequency oscillation devices as a failed project. This was the reason for his extremely critical reviews of the work of Marconi and other researchers who developed high-frequency radio. Tesla began working in a field that now has more enemies and critics than any other field in this century. Now Tesla began to explore the ether with great interest. Tesla believed that dielectric fields were actually made of ether currents. Theoretically, it is then possible to obtain an unlimited amount of energy by capturing and driving a natural dielectric field line into a conductor. The problem was that none of the normal materials available could resist the ether enough to get the slightest force impulse out of it. With a flow so rarefied that it penetrates any known material, the kinetic energy contained in the dielectric field lines remained an inaccessible energy source. Tesla believed he could find the secret to capturing this energy, but it would require an unusual kind of material. Tesla viewed tension as flows of ether under various states of pressure. By increasing this pressure, it was possible to produce enormous energy from the ether, where the observed voltage would become extremely high and luminescent. This was exactly the state that Tesla believed he was getting in his transformers. In fact, Tesla never tired of repeating that his transformers produced powerful movements in the ether. In one truly amazing experiment showing this phenomenon, he described receiving a sequence of very rapid pulses, followed by the appearance of cool, misty white streams penetrating a yard into the surrounding space. They were cool to the touch and safe. If they were electrical in nature, their potential would have reached several million volts. Their harmlessness is due to their wave-like nature, which is completely unusual for electrical currents. Of course, to understand Tesla's technology, it is necessary to discard the idea that electrons were the working fluid in his energy-emitting devices. When the lower end of the coil was connected directly to the dynamo, a stream of high-voltage ether was emitted from the upper terminal. When Tesla described his new technology in his patents, he spoke of light-like rays and natural environments. The former term referred to the tightly compressed jets of ether that were emitted from his transformers along infinitesimal beams, and the latter referred to the atmospheric ether with which all his technology was imbued. It is impossible to understand Tesla technology without opposing points of view on the ether. Many analysts reject his concept without preliminary searches and studies, which were obtained in many experiments. For example, by Eric Dollard. Tesla put forward the idea that streams of ether were pushed through his transformers under the influence of natural increased pressure and accelerated in the form of a sharp electrical discharge. Tesla's apparatus cannot be fully understood or explained as an electrical system. Tesla technology must be viewed as a technology of ethereal gas, which can only be explained through gas dynamic analogies. It is now easy to understand how such emitted rays, streams of ethereal gas under high pressure, can penetrate both metals and insulators. These powerful rays can often penetrate various materials with inexplicable ease. Electricity is not capable of generating such a miracle. Tesla also now understood why these discharge streams produced quiet hissing sounds, like gas escaping under high pressure. Ether gas under pressure. Tesla was intrigued. He successfully released the mysterious radiant current normally bound and compressed in electrical charge carriers. It is released by unidirectional pulsed discharges of high voltage and short duration. What other possibilities can ethereal gas technology bring? The original cylindrical coils were quickly replaced by tapered coils. Using this strange geometry, Tesla was able to focus the gas dynamic component, which now rose from the tip of the coil as a burst of hissing white light. Tesla recognized that these shockingly white and awe-inspiring discharges were actually energy losses. Powerful energy distribution stations would now distribute this energy radiation in all directions. Flame-like discharges gave energy the ability to form waves in space. This could lead to unwanted energy losses over long distances. Consumers would not receive the required and constant flow of energy. If he was going to use his energy transformers to transmit with great efficiency, he would need to suppress these flame-like discharges. But suppressing these excessive bursts of ether has proven problematic. Tesla found out that the white flickering streams were absorbed by large volumes and masses, in which the streams became stuck, filtered, and destroyed. Using copper spheres on top of the transformers caused the streams to significantly absorb the white flames. Now the energy was distributed in space as intended, but a new problem has appeared. Copper spheres, struck by high-voltage currents, became conductive and destroyed electronic components. This phenomenon was inseparable from radiation and gave rise to very dangerous phenomena. The problem arose due to conductivity, in the case where a spherical copper ball was compressed throughout the entire volume. White flickering streams penetrated the copper and tore electrons out of it. These pollutants concentrated and came out as dangerous blue stabbing arrows. In comparison, the white flame-like discharge was a gentle and harmless stream. Comparing both cases, Tesla saw the difference in charge carriers. One day he almost died when one of these arrows jumped a meter into the air and hit him right in the heart. The copper spheres had to be replaced with other scattering components. Metals were not suitable here since they were natural electron storage facilities. Tesla came to the conclusion that metals produce electrons when exposed to these special fiery white streams, when the carriers of the white flame begin to concentrate in the crystal lattice of the metal. Now he was studying how the very air around the transformers produced a strange self-glow. High-frequency coils have never produced such light, a bright white crown that even increased in diameter. The glow from the Tesla transformers gradually increased. Tesla described a growing column of light that surrounded each ascending conductive line in the air, connecting to his transformer. Unlike normal high-frequency oscillations, the effects of Tesla's radiant energy increased over time. Tesla found the reason for their growth process. Although there was no change in the source of the discharge, the radiant energy never reduced the work done on any space or material exposed. Like unidirectional pulse discharges, radiant electrical effects added up and accumulated. In this regard, Tesla saw a multiplication of energy that seemed completely anomalous to ordinary engineering calculations. It was easy to control the lighting in the room by adjusting the output voltage of the transformer. The light from this type of illumination was quite bright to human perception, but it was almost impossible to photograph. To do this, Tesla used long exposures, and only then did the faintest image of the streams appear. This strange impossibility of photographic capture was the exact opposite of the radiance felt by the eye, which required delicate control. Tesla also designed, made, and used large spherical lamps that required a single external input to produce radiant energy. Despite the varying distances to the source of radiant energy, the lamps always glowed brightly. In terms of brightness, they approached arc lamps and were superior to any standard Edison incandescent light bulb of the same size. Tesla could also easily control the heating of any space. By changing the voltage and pulse duration of his transformers, he could heat the room. Cool currents could also be caused by certain pulse duration settings. The key to producing any action on the ether was the secret of the approach to changing the inhomogeneities of the ether, a process that only Tesla dealt with. Sir Oliver Lodge opined that the only way to get the ether was electrically, but no member of the Royal Society could reproduce this process, with the sole exception of Sir William Crookes. Tesla's method used ether to change the ether. The secret was the separation of ether pollutants from the ether currents at the source itself, a feature which he obtained in his transformers and magnetic arc breakers. Tesla used the power of arc discharges interrupted by a magnet to randomize electronic and etheric charge carriers in metal conductors. By breaking the links connecting them, each component was freed for sorting. This state could not be obtained in arc gaps, where the charges could oscillate in opposite directions. In such devices, electronic carriers suppressed the release of ether, and while ether was present in the discharge, it could not be separated from the mixed current. The incredible efficiency of the magnetic arc gap for producing etheric currents followed from several principles. Tesla saw that electric current was actually a complex combination of ether and electrons. When electricity passed through the spark gap, the main separation process began. The electrons were forcefully pushed out of the discharge gap by a strong magnetic field. However, streams of ether, neutral in charge, continued to flow through the circuit. The magnetic discharger was central to separating electrons from ether particles. Ether particles were extremely mobile, almost weightless in comparison with electrons, and could therefore penetrate matter with very little effort. Electrons could not match the ether in speed and penetrating power. According to this point of view, the particles of the ether were infinitesimal, much smaller in size than electrons. The ether particles carried momentum with them. Their enormous speed was consistent with their massless nature. The combination of these properties was observed when they were large in number. They moved faster than the speed of light, a result of their incompressibility and lack of mass. Whenever a directed radiant pulse of energy arises, an incompressible movement in space immediately arises to all points located on its path. This kind of motion manifested itself in a solid beam, which challenged modern ideas about signal delays in space. Incompressible rays could instantly move to any distance. Even though there was a distance of 300,000 kilometers ahead, the impulse reached this point as quickly as any other. This is superluminal speed, instantaneous transmission. Radiant matter behaves incompressibly. The effect of this is that this stream of radiant matter, almost massless and hydrodynamically incompressible, is pure energy, radiant energy, free energy. This was definitely a phenomenon that was in no way consistent with other manifestations of the impulse. Tesla, in contrast, called these pure ethereal emissions radiant matter and radiant energy. Neutral in charge and infinitesimal in mass and size, radiant energy was like nothing else. If you ask whether radiant energy can be compared to any other physical phenomenon known today, the answer is no. We cannot draw parallels between radiant energy and light energy, as science previously believed. Even though it is very similar to light, radiant energy has properties that the light we can receive does not have. Therein lies the problem. Tesla technology is pulse technology. Without an intermittent unidirectional pulse, it's impossible to obtain the effects of radiant energy. The production of radiant energy requires special energy equipment that produces short, rapid pulses. These impulses must be obtained by means of an explosive opening circuit breaker, as Tesla prescribed.
Before we get out of here, I just want to let you guys know that I offer memberships on my channel now. It's a really cool thing. I do behind the scenes stuff. I give you more information. I also put things out early on it. All of my Fringe Think Tank Star Trek episodes will be on there. I just put out another one, a number 7 episode. Also, you're going to get emojis on there that you can use in the live chats. They're pretty cool. And as we grow our membership, I'll be able to put more emojis out there. Just a fun way to liven up the chat a little bit. Don't forget to like, share, subscribe, and comment, and have yourself a great day. Thank you very much.